Welcome. Here's a video on parent functions, and we're going to do a couple. And I'm going to use Desmos. It's a free online graphing calculator. You can find it by just typing into Desmos on um, your Google search, and it'll come up. It'll say free beautiful math, and then just click on start graphing. So I'm going to do a couple. And the very first, and I'm going to explain how to do this on your computer. We're going to type in a constant y equals 3. And you can see here is the graph y equals 3. And the reason why it's y equals 3 is because no matter what your x value is, if your x value is 2, your y value is 3. If your x value is 4, your y value is 3. So this is a constant, y equals 3. And um, they create a slider here, and you can see as the slider goes up and down, you have different values. So if I went to like y equals -6, you can see it's a horizontal line going through y equals -6. All right, so that's my first one. That's just a constant function. Here's a linear function, and the parent function is y equals x. Um, Now you may recall y equals mx plus b. This is when m is 0. I'm sorry, when m is 1 and b is 0. So y equals 1x plus 0. It's the same graph. There's 3 points I want you to be aware of. The first is the point 0, 0, 1, 1, and -1, -1. But this is a linear function, and you can see at -2, when x is -2, y is -2. Because really, remember, my graph is y equals x. So when x is -1, y is -1. When x is 0, y is 0. So that's a linear function. I'm going to do a quadratic, and you'll recall that normally it's y equals ax squared plus bx plus c. Here, if you type in y equals x and then hit this a squared button, you get this. So that's y equals x squared. Now, there's really 3 points that I want you to notice here. One is when x is -1, y is +1. That's because the -1 squared is 1. When x is 0, 0 squared is 0, y is 0. And when x is +1, you get 1 squared, which is 1. And so that is a quadratic function. If we want to make it a cubic function, and just get rid of this 2 and put in a 3, and now you'll get this graph. And now this is important because the last graph, and I'm just going to go back to it real quick. Actually, you know what I'm going to do? I'm going to add a function, y equals x squared. You'll notice for y equals x squared, it comes down and then goes back up. But for y equals x cubed, you'll notice that it starts in negative infinity, and as it's moving from left to right, it goes through the origin, 0, 0, and up towards positive infinity. If you take a look at -1, when x is -1, y is -1, and that's because the -1 cubed is -1. When x is 0, 0 cubed is 0, y is 0. And when x is a +1, y is 1. So that's something to keep in mind as well. Once again, 3 points that should help you sketch this. If I want to do an absolute value function on Desmos, what you're going to do is you're going to go down to here, you just type in x, and that's it. Now, you may or may not know this, but the absolute value of a number is the positive distance away from 0. And if you'll notice, when x is -3, the absolute value of -3 is a positive 3 because -3 is 3 units, 1, 2, 3, from 0. So although x is -3, it's a positive 3 units up. When x is -2, it's a positive 2 units up. When x is -1, it's a positive 1 unit. I also want to emphasize one other point. You can have fractional values as well. As you can see here, 1, 2, 3, 4. These are all worth 0.2. So this is -0.2, and this 0.2 up. When x is 0, it turns and heads upwards at 0. It's similar to y equals x squared. And I'm going to show you once again. Take a look at this. This is actually kind of interesting. Y equals x squared, these points, these 3 points, which should help you sketch your graphs, are the same. So that's kind of interesting just to keep an eye out on. The square root function is, and once again, you go to this little square root sign, and then you just type in x. Now this is a little bit interesting. When x is 0, the square root of 0 is 0. So the origin is one of the critical important points. But when x is 1, the square root of 1 is 1, so once again that goes through. And then the next value over here is 4. When x is 4, the square root of 4 is 2. If you want to find your next value, you have to get to the next perfect square, which is 9, and then you get 3. So you have to be careful when you're graphing this one, because it actually goes up pretty quick, but then it starts tapering off. Take a look. The distance between the first value, 0 to 1, is just 1 unit, and you get a good point. And then you have to go 1, 2, 3 units more, from 1 to 4, to get the second one. But then it's 1, 2, 3, 4, 5, and then it's only an increase of 1. So this is a curve. I don't want you to be mistaking this for a straight line. All right. This is y equals the square root of x is actually a very, very, very important function that we're going to be using quite a bit. This one's a little bit harder to do. It's going to be y equals, this is called a reciprocal function. And it's going to be 1, and we're going to divide it by x. And if you take a look at this, what I'm hoping you'll notice is it gets really close to the x-axis, gets really close to the y-axis, but it never actually touches either axis. And the reason why is, if x is 10, then y is 1/10. Well, that's really close to, I can zoom in, and you can see it gets closer and closer the farther and farther I zoom in. But if x is 100, I could, well, let's see if I can scooch on down. I can zoom all the way out, and there's 100. Well, I could scooch all the way out to 1,000 if I really wanted to. And you'll notice that as I get closer and closer, and I'm going to have to zoom in a lot, but I could zoom in a lot. When x is 1,000, and if I keep on zooming in, you'll see it's not actually at the x-axis. And the reason why is because as x gets closer and closer and closer towards infinity, you're getting a very, very, very small number, closer and closer to 0, but you'll never actually reach it. It's a pretty major concept. And we're going to learn about this later, but you can't actually have 1 over 0. Actually, you should have learned that in Math 100. Remember, anytime you have a number over 0, you're in trouble because it becomes undefined, and obviously that's no good. And now I'm stuck out in the middle of nowhere, and this is no good. Oh, I'll never be able to get back. Oh, there we go. Press home. All right, so x can already equal 0, but if you put in a number very, very small, like 0.000001, you'll get a very, very, very large number, which gets you very close to the y-axis. So this is a reciprocal function. And we're going to talk about that when we talk about domains. And then we have exponential functions, y equals, and I'm going to use 2 to the power of x as our base model. But once again, you'll see that as x gets very, very small, the values exist and they don't actually equal 0. And it might be a little bit hard to see that, but I can assure you that is true. And there you can see there's a tiny bit of a gap, and it'll always work. But you can also see that it shoots up very quickly. The key one here is this: when x is equal to 0, y equals 1. And it gets very, very close. When x is 2, y is 4. When x is 3, y is 9. Y is 8. The exponential functions go very, very close, fast, and we're going to talk more about that later. Anyway, that's it for parent functions. You do need to know all of the parent functions by heart. You can find them in the back cover of your textbook. I hope that's helpful, and like I said, use Desmos to test yourself. All right? Thanks.